Ever wondered how Boolean algebra simplifies complex logic circuits? Well, Boolean algebra is the bedrock of digital logic design, underpinning everything from simple calculators to complex computing architectures. It operates on binary variables and logical operations, providing a framework for designing circuits in computer hardware. At the heart of Boolean algebra are variables and functions. Variables are the simplest form of Boolean algebra and can be either true or false. Functions, on the other hand, take these variables and transform them using logical operations like AND, OR, and NOT. Now you might be thinking, what's the big deal about a bunch of true or false values? Well, when you start combining these variables in complex ways, the resulting logic circuits can become mind-bogglingly complex. That's why it's crucial to simplify Boolean expressions for efficient logic circuit design. So, to simplify these complex logic circuits, we use concepts known as minterms and maxterms. So, what exactly are minterms? Let's break it down. Minterms are product terms where all input variables appear exactly once. These variables could be in their true form or their complemented form. Now, why are they called minterms? It's because they represent the smallest possible product term for a given number of input variables. Here's how we represent them. The minterm for variables is denoted as m subscript e, where I is the decimal representation of the binary value of the input variables. For input variables, the minterm is represented as m subscript I equals a subscript n minus 1, and so on down to a subscript 1, a subscript 0. Let's put this into context with a practical example. Suppose we have a Boolean function with three variables, say a, b, and c. The minterms would be represented as follows. m0 equals a bar, b bar, c bar, m1 equals a bar, b bar, c, m2 equals a bar, b, c bar, m3 equals a bar, b, t, m4 equals a, b bar, c bar, m5 equals a, b bar, c, m6 equals a, b, c bar, m7 equals a, b, t. Notice how each variable appears exactly once in each minterm, either in its true form or its complemented form. This pattern is consistent across all minterms. So, to sum it all up, minterms are a concise way to represent specific combinations of input variables in a Boolean function. They are called minterms because they represent the smallest possible product term for a given number of input variables. As you see, minterms represent the smallest possible product term for a given number of input variables. Now, let's shift our focus to maxterms. To understand maxterms, we must first define what a maxterm is. In the realm of Boolean algebra and digital logic design, a maxterm is a sum term that includes all input variables exactly once. These variables can appear in either their true form or as their complement. The term max in maxterm refers to the notion that it represents the largest possible sum term for a given number of input variables. It's the maximum sum of all possible combinations of the input variables, either in their true form or complemented. To represent a maxterm, we use a notation that might look a bit technical at first glance, but it's quite straightforward once you get the hang of it. A maxterm for variables is denoted as m sub I, where I refers to the decimal representation of the binary value of the input variables. For input variables, the maxterm is represented as a sum of all these variables, which can be either in their true form or complemented. Let's illustrate this with an example. Consider a Boolean function with three variables, a, b, and c. The maxterms for this function would be represented as follows. m sub 0 is equal to a plus b plus c. m sub 1 is equal to a plus b plus not c. m sub 2 is equal to a plus not b plus c. And so forth until we reach m sub 7, which is equal to not a plus not b plus not c. So you can see that each maxterm is a sum of all input variables, each appearing exactly once, either in their true form or as their complement. In essence, a maxterm is a comprehensive representation of all the possible combinations of input variables that can yield a true output for a Boolean function. It's a powerful tool for simplifying Boolean expressions and efficiently implementing logic circuits. So, maxterms represent the largest possible sum term for a given number of input variables. You might be wondering, why are these minterms and maxterms so important? Well, the answer lies in their incredible utility in the world of digital logic design and Boolean algebra. Let's explore this further. Minterms and maxterms have a significant role in simplifying Boolean expressions. Think about a complex expression with multiple variables and operations. It can be quite a task to comprehend and process. Minterms and maxterms come to the rescue here. They break down these complicated expressions into simpler, more manageable terms, making them easier to understand and work with. Imagine trying to solve a jigsaw puzzle. Wouldn't it be easier if we could separate the pieces based on their colors or shapes? That's exactly what minterms and maxterms do. They separate the components of a Boolean expression, making it simpler to piece together the overall picture. But their usefulness doesn't stop there. They also play a vital role in implementing logic circuits efficiently. In digital electronics, logic circuits are used to perform operations on binary inputs and produce a binary output. Minterms and maxterms form the building blocks of these circuits. They represent specific combinations of input variables, thus helping to design the logic circuit in the most efficient way possible. Furthermore, minterms and maxterms are commonly used in Karnaugh maps. Karnaugh maps are graphical tools used in digital electronics to simplify Boolean expressions and optimize logic circuits. By representing the minterms and maxterms graphically, these maps provide a visual way to spot opportunities for simplification and optimization. So it's clear that minterms and maxterms are not just theoretical concepts. They have practical applications in digital electronics, helping to simplify complex expressions, design efficient logic circuits, and optimize them using Karnaugh maps. In essence, understanding minterms and maxterms is crucial for digital designers when optimizing logic circuits and expressing Boolean functions in a more compact and efficient form. Let's quickly recap what we've learned about minterms and maxterms. Minterms, representing the smallest possible product terms, are formed when all input variables appear once in true or complemented form. An example would be minterms for a 3-variable function, which can range from a bar b bar c bar to a b c. On the other hand, maxterms represent the largest possible sum terms, with all input variables appearing once, either in true or complemented form. An example of this would be the max terms for a 3-variable function, which can range from a plus b plus c to a bar plus b bar plus c bar. These terms are more than just mathematical curiosities. They hold a central place in Boolean algebra, playing a crucial role in simplifying Boolean expressions and optimizing logic circuits. Whether it's for designing digital logic circuits or just understanding Boolean functions, the knowledge of minterms and maxterms is essential. With a good grasp of minterms and maxterms, you're now better equipped to simplify complex logic circuits. Keep exploring and happy learning.